Mars and Its Canals by Percival Lowell. Part 4, Explanation. Chapter 28, Constitution of the Canals and Oases. As rational science does not rest content with raw results, it now becomes obligatory, by marshalling the facts to suitable discussion, to seek to find out what they mean. Now, so soon as we scan these phenomena for some self-interpretation, we perceive one characteristic of the lines which at once appears to direct us to their nature and justifies itself as a signpost with increasing certainty as we read on. This trait is the very simple yet most significant one of showing intrinsic change. The lines alter in visibility with time. This primary proclivity we do not even need the cartouches to establish. That the lines change is palpable to anyone who will watch them long enough. Schiaparelli was struck by the fact early in his study of the planet, and it forces itself on the notice of any careful observer who compares his own observations with one another at intervals. But, though the cartouches are not needed to a first revelation of mutability, they serve to certify and precise it to much further information on the subject. For that these changes are not extrinsic, that is, are not caused by varying definition, distance, or illumination, they make patent even to those who have never seen the things themselves by disclosing respective differences of behavior in lines similarly circumstanced optically. The change is therefore intrinsic, and the question arises to what such intrinsic change can be due. In searching for cause, attention is at once attracted by another series of transmutations that manifests itself upon the disk in the orderly melting of the polar caps. For the existence of the two set of metamorphoses suggests the possibility of a connection between them. The inference is strengthened when we note that not only are both periodic, but that furthermore the period of the two is the same. Each polar cap runs through its gamut of change in a Martian year. The canals also complete their cycle of growth and decay in a Martian 12-month. The only difference between the two is that each polar cap has but one maximum and one minimum in the course of this time, while most of the canals have two of each, though the maxima are not alike, nor the minima either. Not only is the period of the two series of changes the same, but the one follows the other. For the development of the canals does not begin till the melting of the polar cap is well underway. Now, as the polar cap disintegrates, it gives rise, as we have seen, to a dark belt of blue-green, which fringes its outer edge and retreats with it as it shrinks. This tells, directly or indirectly, of a product let loose. After this belt has been formed, the canals nearest to it proceed to darken, then those a little farther off follow suit, and so the wave of visibility rolls in regular routine down the disk. Here then, at the outset, we have a chronic connection between the two phenomena, the disintegration of the cap and the integration of the canals. Of water we saw that the caps were undoubtedly composed, and to water, then, let loose by the melting of the cap, we may inferably ascribe the thaumaturgy in the development of the canals. But it is not necessary to suppose that this is done directly. That the increased visibility of the canals can be due to a bodily transference of water seems doubtful, if for no other reason than the delay in the action. Considerable time intervenes between the disappearance of the cap and the appearance of the canals, except in the case of such as have been covered by it. Transformation consequent on the transference, however, would account for the hesitancy. A quickening to vegetal growth would produce the counterpart of what we see. If set free from the winter locking up, the water accumulated in the cap then percolated equatorward, starting vegetation in its course, this would cause the increased visibility of the canals and, at the same time, explain the seeming delay by allowing for the time necessary for this vegetation to sprout. This is certainly the most satisfactory explanation of the phenomena. Thus started, the vegetal quickening would pass down the planet's surface and give rise to what we mark as seasonal change. But, though in one sense of seasonal character, a little consideration will show that it would be quite unlike the seasonal change which we know on Earth. Could we see our Earth from some standpoint in space, we should mark with the advent of spring a wave of verdure sweep over its face. If freedom from cloud permitted of an unimpeded view, this flush of waking from winter's sleep would be quite evident and could be seen to spread. Starting from the equator, so soon as the sun turned north, it too would travel northward and, distancing the sun, arrive by midsummer well into the Arctic zone. Here, then, we should note, much as we note it on Mars, a tint of blue-green superpose itself successively on the ochre ground, but mundane and the Martian vegetal awakening would differ in one fundamental respect. The earthly wave would be seen to travel from equator to pole, while the Aryan travels from pole to the equator. Though clearly seasonal in character, both of them, the transformations would be opposite in action. Some other cause, then, must be at work for what we are familiar with on Earth. This other cause is the presence or absence of moisture. Two factors are necessary to the begetting of vegetal life, the raw material and the reacting agent. Oxygen, nitrogen, water, and a few salts make up the first desideratum. The sun supplies the second. Unless both be present, the quickening to life never comes. Now, the one may be there and the other not, or the other there and the one not. On Earth, the material, including water, is, except in certain destitute localities, always present. The sun is it that periodically withdraws. Observant on the return of the sun is, therefore, the annual recurrence of vegetal growth. On Mars, on the contrary, water is lacking. This we now know conclusively from other phenomena the disk presents, which have no connection with the present investigation and are, therefore, unprejudiced witness to the fact. No permanent bodies of water stud its surface. That the so-called seas are traversed by dark lines permanent in place is one of several proofs of this. The only surface water the planet knows comes from the melting of its polar caps. Vegetation cannot start until this water reaches it. Consequently, though the sun be ready, vegetation must wait upon the coming of the water, and, starting from near the pole, follow the frugal flood equatorward. Now, such contrariety of progression of what we should observe in the case of the Earth, could we view it from afar, is exactly what the curves of visibility of the canals exhibit. Timed primarily not to the return of the sun, but to the advent of the water, vegetal quickening there follows, not the former up the latitudes, but the latter down the disk. For better understanding, the two curves of phenological quickening, the mundane and the Martian, are shown in the diagrams. The plates represent the surfaces of the two planets, that of the Earth being shown upside down, with south at the top, as to agree with the telescopic depiction of the topography of Mars. The stars mark the epoch of the dead point of vegetation at successive latitudes, the time increasing towards the right. The curves, it will be noticed, are bowed in opposite ways. The bowed effect is due, in part, to Mercator's projection. In part, it may represent a real decrease in speed with time. But what is strikingly noticeable is the opposite character of advance to the right, the one curve running up the disk, the other down it. This shows that the development of vegetation proceeded in opposite directions over the surface. Thus is the opposed action of the two planets accounted for, and we are led to the conclusion that the canals are strips of vegetation fed by water from the polar caps, and that the floral seasons there as affecting the canals are conditioned not as they would be with us, directly upon the return of the sun, but indirectly, so through the direct effect upon the polar snows. Once adventured on the idea of vegetation, we find that it explains much more than the time taken by the wave of canal development down the disk. It accounts at once for the behavior of the canals in the three northern zones, the polar, Arctic, and subarctic. The mean cartouches of these three zones dip down at their latter end instead of rising there, as in the case with the cartouches of the mean canals farther south. This dip denotes that the most northern canals were waning already by the middle of their August, though the others showed no such tendency. While the date of the deposition of the frost in these northern latitudes shows that they were started upon their course towards extinction before the snow itself had covered them. In other words, they were not obliterated, but snuffed out. That their decline was thus preparatory to the coming of the first snowfall or frostfall, sufficiently severe to whiten the ground, so that it did not melt the next day, is suggestive of their constitution. It is clear that they were not abruptly cut off by the frost, but were timed by nature to such extinction. Vegetation would behave in just this way, since evolution would accommodate the career of the plant to its environment. The first question to present itself chronologically in the canal's annual history is connected with the size of the cap. Unfortunately for the simplicity of the phenomenon, this cap is not an extensionless source of flow, but an extended surface melting from the outer edge in. It would seem, therefore, that water liberated from the outer parts should have an effect before the main body of it were ready to begin its general march down the disk. There should be, one would think, at least a partial action locally before the main action got underway. Now, there are certain canals that show cartouches increasing apparently from the time the observations began, and the most pronounced is the Jaxartes, which lies of all the canals observed the farthest north. Now, the cartouches were founded on canals quickened from the North Polar Cap. The farther north the canal, therefore, the greater the likelihood of its showing the phenomena. That we note such canals is therefore not only not subversive, but actually corroboratory of the law it seems at first to shake. That all the canals of these zones do not show alike cartouche profiles is not necessarily a part of them being dependent, not upon the earlier, but upon the latter liberated flow, and thus partaking in the general law which grows uniform lower down the latitudes. As the action from one polar cap proceeds, not only down to the equator, but across it into the planet's other hemisphere, it appears that much, at least, of the surface of Mars has two seasons of vegetal growth, the one quickened of the North Polar Cap, the other of the southern. How far the polar spheres of action overlap it is not possible at present to affirm, as the canals at this opposition were only visible to 35 degrees south latitude. That the North Polar quickening goes down so far is vouched for, and it is probable from other observed phenomena that it goes farther. The alternate semi-annual quickening also discloses itself directly in the cartouches. The previous semestral growth from the South Polar Cap actually showing in them before the impulse from the north began. The slow falling of their curves to the minimum preceding their latter rise is nothing less than the dying out of the effect started 6 months before from the south. The gentler gradient of their fall proclaims a gradual lapse, just as the subsequent sharper rise points to the advent of a fresh impulse. And this deduction seems to be borne out by another circumstance. There is some evidence of the decrease in the pre-minimal gradient southward. This is telling testimony to the source whence the impulse came. For if it originated at the south and traveled northward, the southern canals would be the first to be affected and the first to die out, and thus show a longer dead season, exhibited in the cartouches as a more level stretch. Lastly, the explanation of the canals as threads of vegetation phase in with the one which has been found to meet the requirements of the blue-green areas. While the fact that they prove to develop as they do, reversely to what would take place on Earth, is exactly what all we have latterly learnt about the surface conditions of the planet would lead us to expect. From what has just been said, we see that the latest observations at Flagstaff confirm the earlier ones, and, what is especially corroborative, they do so along another line. The former were chiefly static, the latter kinematic. In other words, the behavior of the canals in action bears out the testimony of their appearance at rest. End of section 30. Recording by Michael Knowles, Fort Worth, Texas.